All right, everyone, let's go ahead and look at your exam. So I'm going to go over to our course and look at our week 9 announcement. And in here, there's a practice exam 2 and practice exam 2 with answers. Okay, so let's go ahead and look at this. All right, briefly describe what is a control structure. Okay, I'm going to go through some of these kind of quick. You guys can just look them up in your book and other things like that. I'll probably spend more time on the coding ones. But if you remember, a control structure is it just controls how a program is executed. Okay, the default control structure is from top to bottom, left to right, but different things like functions and if statements and for loops, any type of loop, and different things like that will change the order of code execution. Okay, so those are all examples of control structures. All right, and if at any time, if anyone has a question, just feel free to stop me. Given the following JavaScript code, what will the computer output? Okay, two things. I talked about this a lot in our last exam prep video. Thinking through these things is great, and I highly encourage you to do that, but I also highly encourage you to actually run it and not have any question about it afterwards. Okay, so let's think through it first and then let's run it. Okay, if you guys are able to run any piece of code and see what it outputs, I would much rather have you be able to do that than think through something and assume that you have the right answer. Okay, so var 1 equals 7, 2 equals 1 plus 3, so 2 is at 10 currently. Message equals neutral. If 1 is less than 5, false. I'm looking for another if state or else statement, nothing. So we would alert message, which would be neutral. Okay, so the big thing here is that this else statement is connected to this if statement. Doesn't care about the first one. So yes, 2 is greater than 6, but we never even get to that piece of code because 1 is not less than 5. So we would just alert message as neutral. Okay, let's test it out. Now that I've gotten my answer, I'm going to actually check it so that I don't have to have any question. So I'm just going to open this up. I'll just take everything out of this function because I know I'm calling it. So if you have like a template file or something like that that you can use, go for it. All right. I'm just going to clean this up a little bit so that it's a little bit more clear as to what's going on. All right. So these red errors are coming in because these funky characters from my PDF don't exist in JavaScript. Okay, so I'm just going to replace those with nice quotes. All right. Again, I can select this and hit Control D to select the next instance of that string and delete those and replace all that. All right, no red errors. We have the right type of strings. Okay, I'm going to copy this or copy the file path and open it in our browser. I think we already have it open. I'm going to refresh. And then in here, I have my in-class example. Ooh, I took out the alert. That was supposed to be there. Sorry, guys. And then we had an alert message. Okay, so I'm going to refresh and then play the game and it alerts neutral. Okay, if I wanted to see why that was done, I could put a breakpoint right here, hit play game, be like, okay, message is, whoops, let me refresh that. So message is currently neutral. Is 1 less than 5? False. Jumps all the way down to alert message. And that's that. Okay. Now, there's a lot of different ways that you can do this. If you have a piece of code like this, especially if it has an alert or something like that, I can just go over to W3 Schools, click on any try it editor, and just run it. So I'd have to put a script tag in here, and I'd paste that, and close my script tag. But once I have that, then I could put a button in here to call that function. Okay, and I could test it out the same way that we did the other one. So I'd say number, guessing, or guess game, the name of our function. And then I'd say play. So if I run this, you can see my button here, and it'll run my function the same as the other one. Okay, so there's lots of different ways that you can do this. For me, I usually just end up, I just grab like a temporary HTML file that I already have, kind of like the bare bones of, and I just put in the code so that I can run it in my browser. Okay. All right. The following JavaScript code contains an error. Rewrite it so it is correct. Assume the variable age exists and has a valid value. Okay. To be able to rewrite this, you have to know what the error is first. So thinking through this logically, if I say age is greater than 3 and less than 4, that makes sense when I say it in English. However, I need something between these two. Okay, I would have to say age is greater than 3 and age is less than 4 or something like that. We're currently missing that, so if I just have less than 4, it would not give me my desired output. Okay, the other thing that doesn't really quite make sense is if I put in age is less than 4 right there and age is greater than 3, that will never be true regardless of what age is. That's impossible for it to be greater than 3 and less than 4, I guess, unless it's a float. Okay, so I might also switch that to a for or to an or operator as well. Okay, so if I took this, I might change it into something like, see that red arrow that popped up as soon as I pasted it in there? Because I need something there. Okay, so age is greater than 3 and age is less than 4. So if I had like var age equals 3.5, you know, or something like that, then this would be true. Otherwise, I might want to change this into an or, okay, which would always be true. So you'd probably want to leave it as an and. But okay, but the main error there was it didn't have age in that second part of it. The following JavaScript code contains a logical error. Rewrite it so that it is a meaningful check. Okay, so the last one was a syntax error. I could tell that because as soon as I pasted it into my text editor, it had that red error, that red underline. This one, if I paste this in, unless my text editor is like super duper smart, it's not going to tell me a thing. Okay, that red line popped up just because I didn't have my curly braces. Okay, so let's look at this. Oh, there is a syntax error. That's funny. I'm gonna have to update that. Okay, so there was a syntax error. It was missing a closing parenthesis. Okay, but let's think through this logically and find our logical error. So age is less than 4 and age is greater than 7. That's impossible. So I could change this to that. All right, if I wanted to isolate two different ranges, I could say if age is less than 4 or age is greater than 7. All right, so that would exclude ages 5 and 6. Another thing that would be acceptable here is making it that inner range. So I could say if age is greater than 4 and age is less than 7. Okay, and so that would say give me numbers 5 and 6. All right, so either one of those would work. Either one of those would make this a useful statement depending on the use case. Okay. All right, no questions up to this point. You guys are doing okay? Okay. Given the following JavaScript code, what will be output to the user? All right, so remember our 2 steps. First, think through it. Next, run it. So let's think through it. var 3 equals 7. These questions are awful. var 4 equals 5. var 5 equals 4 minus 3 times 4. So let's put our numbers into here. So var 5 actually equals 5 minus 7 times 5. 7 times 5 will happen first because of the multiplication, so that'd be 35. And then 4 is still 5, so pretty sure we'd end up with negative 30 right there because it would end up with 5 minus 35. And then we alert 5 minus 2, which would be negative 32. All right, so I thought through it. I'm pretty sure it's 32, okay? But again, let's run it, okay? This one will be a really easy one to run. I could even just hit F12, open up my console, clear out everything that's there, paste it, and oh, I don't think it liked that space. No. Oh. I think it's because of my PDF document. I don't think that's minus. There we go. So yeah, it was 32. So these errors came up because I actually had like some like Microsoft Word type hyphen instead of just like our minus. So similar with the quotation issue that I had with the last one that I pasted. but hopefully you won't have those issues on your test. It's just my PDFs. Okay, but anyways, I ran it, okay, and I could see number 30, negative 32 pop up immediately. Okay, and I could have done that same thing. I could have come into here and just replaced all of this and pasted it. Now my text editor is like, hey, there's something wrong with that. I don't know what it is. Okay, and I'll be like, well, that's weird. Okay, but I could do that exact same thing and see what that is when I run it in the browser. Okay. All right, let me close this. Next one. Rewrite the following condition using and instead of or to produce the exact same meaning. Okay, so these ones are kind of tricky. Again, you have to think about the ranges that these will encapsulate. All right, so right now I'm saying A is less than B or B is greater than or equal to 5. All right, so I'm going to copy this and I'm just going to put this inside of an if statement because that's usually where we see logic like this. All right, I could also see this inside of like a while loop or something like that. But an if statement would be a very common place to see this. All right, so if I was going to write out this exact same thing, but let's see, what did it say? Using and instead of or to produce the exact same meaning. Okay, this brings us back to our good old buddy De Morgan and his laws. All right, so if I was going to think through this, for everything that where A is less than 3 and B is not less than 5, so B is greater than or equal to 5. All right, so I'm going to write out like the exact opposite thing here. I'm going to say A is greater than or equal to 3, which is the exact opposite, right? And I'll say B is less than 5. So right now, these are complete opposites. Okay, does everyone agree with that? So as long as I just go like that, then this entire thing would be negated. Now, with an if statement right here, it won't really like that. It's expecting a parenthesis here. So the way I would negate this entire thing is I would put it inside of another set of parentheses and negate that. Okay, and that would give me the exact same result set. Okay. Questions on this one? It's a little tricky. Okay. All right, given the following JavaScript code, how often will the program output skunks? Remember our 2 steps, we'll think through it, and then we'll run it. Var x equals 3, do document write skunks break x plus equals 2 while x is less than 12. Okay, so x is equal to 3, it'll output once, then 5, then 7, then 9, then 11, and then it'll increment that again. And so I think it'd be 6, okay, because 11 would still be less than 12, and then we'll go back up, write it down one more time, and then x would pop up to 13, and so we wouldn't loop again. So I'm pretty sure it'd be 6, but let's run it, okay? I already know that my quotations are gonna be an issue, okay? I'm gonna paste this in here, tab it over nicely. My browser's, or my text editor's like, what are those characters? Okay, so x equals 3, do this while x is less than 12. All right, and then what was the question? How often will the program output skunks? Okay, well, let's run this and let's see what happens. And then copy the file path. Oh, it's already here. Refresh, and then I'll move that. Play game. 1, 2, 3, 4, 5. See, I was wrong. Glad I checked. Okay, it's only 5 times. Okay, so again, remember the 2 steps. Think through it, trying to figure out what the problem's saying and come to your answer, and then run it. Given the following JavaScript code, how often will the program output goodbye? Var q equals 12, while q minus 5, which would be 7 in this case, is less than 8. Document.write goodbye break q minus minus. So the first time we loop through this, it'll already be 7. And if we're only subtracting from q, then I'm pretty sure it'll be infinite. Okay, but if I wanted to test it, I would take this and copy it over here, paste it in here, and I have this funky minus sign and funky quotation marks and no errors. I'm going to come into here, refresh, and play game. Okay, notice how my button is still pushed. Okay, and I like can't do anything with my page. And my cursor is like all funky. All right, it's because it's looping a lot right now. All right, so it is infinite times. If I wanted to check that, then I could use like an alert. I could put a breakpoint in here, but right now I can't put a breakpoint in because it's an infinite loop. Okay, so I'm going to close this tab. Let me. Thank you, Chrome. All right, desk check the following code. Parse float document, I get element by ID. So that is going to be 23, okay, for start. End is 70.3. For var step equals 1, a cum equals start, a cum is less than end, a cum plus equals step. All right, so I don't know if you guys knew this, but this first chunk inside of a for loop, you can actually declare as many variables as you want. Very rare that you see that done. Usually you just see one. In this case, they're declaring 2. And then we have our Boolean condition, while a cum is less than end, and then how we're going to change our loop, a cum plus equals step. All right, if a cum is less than 50, step plus equals 3, else step minus equals 1. All right, you guys can totally think through this if you want to. That's awesome. What I'm going to do instead, because I'm lazy, I'm going to grab this code, and I'm going to put it into my text editor, make it nice and pretty, make it look exactly like that other one did. Except it's pasting all funny. So let's see. For if step else. Okay. Put that there. Put that there. Oops. And then just my personal preference. I like having those on the end of the lines. Okay. So if you're wondering how I did that, if you hold Control and then click again, you can put a cursor anywhere you want. Okay, and then I hit like Shift Home, and I could delete all that. All right, so I'm going to save this. To run this, I will need an input box, but I know that our input is 23. So instead, I'm just going to say 23, okay, because that's what start is. Now I'm going to have to open this up in a new tab because our last one died for my infinite loop. Copy path, paste it, run it, F12, and we're doing a desk check on this one, so I'm going to put a breakpoint on line 7 and hit play game. Okay, now looking at my question, I'm going to have to fill this in as we go. All right, I need to know what end is, and every single time step gets a value or a cum gets a value, I'm going to write one in. All right, so if this is your exam and you have a desk check, split your windows open or in half, have like your exam on one side and then have an empty tab on the other that you can like step through the code and run it. Okay, so I'd step through, start is 70 or is 23, end is 70.3. Okay, there's my first number. I'd be like, oh yeah, 70.3. Okay, and then I'm looking for step and a cum to change. Well, step just got the value of 1. A cum just got 23, so I'll put those in there. All right, and then I would check every time something changes. Oh, step just bumped up to 4. And then a cum is up to 27. And now step is up to 7. And a cum is up to 34. Okay, and so I would just loop through this, and every single time one of them changes, I would just hover over it, be like, okay, what's that one? Okay, we're adding steps. What's step now? Okay, and then having them open side by side, you just put in those values as you loop through it. Okay. Any questions on this one? You guys are easy today. Okay, well, I will let that go then. All right, let's do a couple of programs. Write a complete JavaScript program that inputs 2 integers from the user. Real quick, before I go into this, if you get a question on your test that says, write a defining table for a program that does this, just write the defining table. Okay, I had a lot of people on the last exam writing out the entire program. I'm like, okay, I see your logic and that's fine. And I gave you 100% for the logic that was there, not for the code, all right? So if it says write a defining table, just do a defining table to save you time. All right, this one, however, is not that, okay? This, you have to write a complete JavaScript program, okay? That inputs 2 integers from the user, min and max, and then outputs all the integers whose squares are between min and max inclusive. Okay, so if I typed in 10 and 100, 4 would be in that list because the square of 4 is between that range, is inside that range of 10 and 100. You may use the following code as a starting point. Let's do that. So I'm going to copy this, even though it has, oh, this one's quote. Well, I guess we'll see if these quotes are okay. Is that, well, those quotes are okay. I wonder what was going on with the other ones. All right, I'm going to tab all this over, make it look nice and pretty so I can see exactly what's going on with my code. And then I'm going to go over my browser and run it so I can kind of visualize what I'm seeing. All right, so min, if I type into 10 and 100, click, nothing happens. So let's write this thing out. Okay, so min, I think that looks good. We have our max. Our button isn't calling anything. So I'm going to say get numbers. And I'm going to copy this and I'll say function get numbers. And in here, we're going to need an input and some processing and some output. Okay. The input, all right, we need 2 numbers from the user. Okay. So in here, I would say var min equals document dot get element by ID min dot value, and we should probably parse that. So I'd say parse int and close that with a parenthesis. Copy and paste. If you just put a cursor on a line and hit Control-C, it'll copy the entire line with its new line character at the end. And then I can just hit Control-V and paste that whole line. And then click here, hit Control-D to change both of these at the same time to max. Okay, there's my input. Our output is going to be the square, or wait, hang on. What is our output? Integers whose squares are between min and max inclusive. Okay, so I'm just going to copy that and paste it right there. Okay. How about our processing? What do you guys think? What thoughts do you have? Oh, we got a couple comments in the chat. All right. Shonda, either you're like speaking in Morse code or that was another child. I'm assuming the former or the latter. You're good, no worries. Okay, so let's see. If I was going to do this, I would say loop through min to max. Check each number for a square root. I don't know, does that sound okay, you guys? Because if I'm looping from 10 to 100 and I have to get numbers like 4, as soon as I come across 16 and I have a square root of 16, it would pull up 4. Okay, so as every time I find a number that's square rootable inside that range, does that sound like, I think that makes sense to me anyways. No objections? All right, let's do it. Hopefully it works. All right, let me just look at this one more time. Min and max, and then outputs all the integers whose squares are between min and max inclusive. I think that sounds good. So processing, let's go ahead and say, we'll go ahead and make a message again that will output to the user. And I'll say document.getElement by ID. They named it output down here. .inner HTML equals message. Our output's done, ready to go. Now for message, I'm going to say for I equals min, while I is less than or equal to max, because they said inclusive, I plus plus. Oops. All right, if math.square root of I, let's see here. So if I'm looking for just whole numbers, which I think we are, assuming that this would get me a square root, because technically I could say, you know, like the square root of 10 would be like 2 point something, or 3 point something, I mean. So, but I want to get a whole number, so I could say modulus 1 is equal to 0. okay? You know, we use modulus 2 is equal to 0 to check for an even number. Well, if it's evenly divisible by 1, it means it's a whole number, okay? Hopefully this works. We'll see, okay? All right, math.square root at index of I, while we loop through min to max, is equal, modulus 1 is equal to 0. Then we'll say message plus equals I plus break. We'll see if that works. Okay, I'm thinking of just like making a new line, so we'll just have like a nice list of these. All right, well, that's all I had in my defining table. So let's go ahead and run this and see if we're anywhere close. So I'm going to say 10 to 100. Let's see, we should get 8, 9, and 10. So we should get like 4 through 10 in here. Ooh, okay, so we did get all the squares, but we didn't get the numbers. All right, because we need the integers whose squares are between. So we got the squares, so that's a pretty simple fix. So instead of saying, I'm going to make a new variable right here, and I'll say root value. So var root value equals math.square root at index of I. Because I'm going to have to use this same thing twice. So instead of writing that out twice, I'm just going to make a variable named root value, and I can use that anywhere I want to. Okay, so now let's refresh this, and I'll say 10 to 100, and we get 4 through 10. Okay. All right, let's look back at our practice exam, make sure that we're doing things right. 2 integers from the user at min and max, and then outputs all the integers whose squares are between min and max inclusive. All right, so I think we did it. Any questions? Okay, sounds good. Let's look at our next one. I think we have one more. Yep, last one. Write a complete JavaScript program that finds and outputs the third perfect number. A perfect number is one whose factors, including 1, but excluding the number, add up to the number. For example, the first 2 perfect numbers are 6, 1, 2, and 3 equal 6, and 28. All of its factors, 1, 2, 4, 7, and 14 equal 28. Oh. All right, so let's do that real quick. They're letting me start off with this, so I'm going to do that. I'm just going to take all of this out and paste that. Whoops, there we go. I'm going to make this nice and pretty again. All right, so we're finding the third perfect number. So I'm pretty sure we don't need any input for that. This, I would imagine, would really make our computer work if we put in a number like 10. I don't even know if there is, I don't even know if they go that high. All right, so we don't have any input. Our output is going to be the third perfect number. Our processing, what do you guys think for our processing? I'm thinking we could loop until we hit the third number. For every time we loop, we would have to loop through the divisors of the current iterator, check if they add up to iterator. Okay, so we're going to loop till the end of the time, or to the end of time, or at least until we hit our third perfect number. And for each one of those, we have to loop through all of the numbers below that. Find the divisors, add them up to a sum value that gets reassigned every time we loop in this parent loop, and then check to see if that sum equals that number. Okay, and then we'll just output that number. All right, so let's do that real quick. So I'm going to go ahead and call a function called get perfect number. I'll copy this and paste up here. Oops. Function get perfect number. All right, and then in here, I'll go ahead and say, let's see, var perfect count equals 0. And then I'll go ahead and just say var output, and we'll just leave that as nothing for now. Okay, we'll assign something to that here in a little bit. We'll have our output here, which will be document.getElementById output, and we'll assign output to that. Whoops. HTML equals output. All right. So we have our output good to go. All right. I don't think I've ever said output so many times in like a 1 minute period. So we have that ready to go. We don't have any input. Instead, I'm just declaring a couple of variables. But then here we'll have our processing. All right. So I'm going to say for, let's see here, for var, let's say I equals 2. Okay. While I is, or while perfect count is less than 3. And we'll go ahead and increment I. All right. Var sum, like I said, we're going to have to declare sum every single time we're looping through the parent loop. All right. So we'll declare sum, and then we'll start looping through all the numbers below that, and we'll check for the divisors and things like that. Okay. So I'm going to say for divisor equals 1, while divisor is less than I, this guy up here. All right. So let's say we're looping through, we're checking like the number 50 to see if it's a perfect number. We would loop through from 1 to 50, or from 1 to 49, sorry, and we're going to check to see if those are divisors of 50. All right. So while div is less than I, or divisor is less than I plus plus. All right. And then in here, I have to check to see if it is divisible by I. So I'm going to say if I modulus divisor is equal to 0, then sum plus equals divisor. Whoops. Okay. So if divisor is a multiple of I, we will add that to the sum for this number. Remember, if I'm like at 50 right now in my big loop, in my parent loop, okay, then I'll be checking every time I get a divisor, I'll add it to the sum. And at the very end, if that sum is equal to 50, we're good to go. That's our perfect number. Okay, so we have our first chunk done. Then down here, I'll say if sum is equal to I. Okay, remember, we're still here in our parent loop. So if our sum after this whole loop, we loop through all the numbers from 1 to that number, if the sum of all those divisors is equal to that number, then we found our perfect number. And I'll go ahead and say output plus equals I. Okay. And then we'll just say perfect count plus plus. Okay, so we have our output there. Perfect count, we're only really going to use this if we wanted to get like an input from the user. If they said, oh yeah, I want to get like the 5th number or something like that, then we could use that. Okay, but let's go ahead and run this real quick and see how it goes. I'm going to refresh. I'm going to put a breakpoint in here for this first time to see how it's working. So perfect number and output are declared. Is perfect number less than 3? Yes, it is indeed. Okay, sum is at 0. Divider will assign to 1. While divisor is less than 2, we'll loop through. And each time I modulus divisor is equal to 0, then we'll add that onto our sum. Okay, so for this case, I this entire time, or I is now 5, okay, and we'll loop through from 1 to 4 to find multiples of 5. All right, and our sum is currently 4, and now it's 5. Okay, I is now up to 7. All right, and we're just going to keep on looping through this until we find that perfect number. I'm going to put a breakpoint down here instead and hit F8. And it looks like we might have a massive loop going on here. We do indeed. All right, let me see if I can close this. All right, we got it closed. All right, so I equals 2, perfect count is less than 3. Equals 2, perfect count is less than 3. I plus plus, our sum equals 0 for div I. So it never even got down here, which means it didn't even find a perfect number. Okay, I'm going to put parentheses around this just in case. And then, Sum plus equals div. Let's try that and see if that works. Reopen that, refresh it. And yeah, it looks like we're in another infinite loop. Okay, head back into here. All right, so perfect count equals 0. Output equals quotes. I equals 2, while perfect count is less than 3. Increment I. Okay. Let's go ahead. So I'm going to try something here. I'm going to put these in front of the number. Okay. So this means that they'll iterate in a different order. So I'm going to open that up. I just saved it. And I'll click. I didn't change anything. Okay. I'm going to close this one more time and pull this up. All right. So I got to figure out why this is causing an infinite loop. So div equals 1. All right, I'm going to put a breakpoint in there again. So we can kind of see what's going on. I'm going to click. All right, so I is equal to 2. Perfect count is currently at 0. Div is now equal to 1. All right, well, div is less than I. I'll increment I. Okay, so it was 2 and 1, so that was a whole number. Okay, so we're never getting out of this loop. Oh, I see it. It's because I'm incrementing I right here. And so this is an infinite loop. I should be incrementing div, our divisor, right here. Okay, I'm already incrementing I in this parent loop, but I never get to that parent loop because I'm incrementing I right here. So let's go ahead and make that our divisor. All right, let's close that again. Hopefully that was our last infinite loop of the day. Refresh, hit click, and we have 628,496. It's a really big number. All right, so I'm going to put a single breakpoint in right here. Okay, I'm going to refresh and I click on that. So I is currently at 6. Oh, okay. So I forgot one last thing. Let that go. So that actually isn't accurate. Okay, that's 6, 28, and 496 that are being displayed. I thought that was a little big. Okay, so right here, I'm just going to add plus a break that we can see the numbers being split up. Because every time we find one, we're assigning that to output or adding it onto output, but we weren't adding anything else. So I'll refresh that. And there we have our first 3 numbers. Okay. All right. Any questions on this one? Okay. As a side note, this exam will be exactly like your last one. Okay. I keep on telling you to use like your developer tools or W3 schools because they are all accessible to you, as is your text editor and your previous programs and your book and anything that I learn, anything on W3 schools. You just can't use other people and you can't search the internet outside of those resources. So yeah, please do use those resources. When you go into the test, I would highly recommend whatever text editor you use, you can just say open folder. If you go into file, and then I could come into here. Let's see, where's my stuff? Go into my class, and I have an entire folder of all the programs that I've written for this class. Okay, and so if I had these readily available, it'd be like, oh yeah, I know that I did that for week 8. How did I do that? And then you could look at it and be like, oh, that's how I did it. Okay, you can use these on your test. So I highly encourage you to use those. and then to run snippets of code as you come across them in your tests. So, all right, you guys, hopefully this has been helpful for you, both doing the chapter 8 problems together a couple of many ways and also going through this exam together. But do you guys have any other questions regarding your test or regarding anything else? All right. Well, everyone, I think I'm going to let you go then. It'll probably take Zoom a couple hours until these videos are available to me, and then I will put them in the spreadsheet for you. But yeah, thank you all for coming, and I wish you the best with the week and the exam. So thank you guys.
Thank you.
Yep. Bye guys.